Hello and welcome. Wherever you are right now, whatever time it is, I'm glad you're here. Take a moment, if you will, to settle in. Let your shoulders drop just a little. Soften your jaw. There's nothing you need to do right now except listen, and even that requires no effort at all. Just let the words come to you, like waves reaching a quiet shore. Tonight, we're going to take a journey together. Not a journey that requires movement or effort, but one that happens in the stillness. We're going to drift through the Milky Way, our home galaxy, and explore some of the most beautiful and calming truths about the vast cosmic structure that cradles us all. These aren't facts that demand your attention or test your memory. They're gentle revelations, soft pieces of wonder meant to ease your mind and help you feel connected to something much larger than the room you're in right now. The Milky Way is always there, even when we can't see it. During the day, the sunlight washes it away. In cities, the glow of streetlights hides it from view. But it's always turning, always present, a river of light spanning the darkness above us. And you, right now, are part of it. You're not just under it or near it. You're in it. You're traveling through it. Every breath you take as a passenger on a spinning disk of stars. So let's begin. Close your eyes if you'd like, or let them rest half open, gazing at nothing in particular. Breathe slowly, in through your nose, out through your mouth. There's no hurry. The universe has been here for billions of years, and it will still be here long after this night is over. We have all the time we need. Let's start our journey. Imagine a river of light spinning slowly in the darkness, not rushing, not tumbling, but turning with the kind of patience that only the cosmos understands. Picture it from far away, as if you were floating in the deep black of space, watching from a distance. You would see it then, the Milky Way, shaped like a great spiral, its arms curving outward in graceful arcs, glowing softly with the light of hundreds of billions of stars. This is what our galaxy looks like, a spiral, not a random scattering of stars, but an organized, elegant structure turning slowly around a central point. The Milky Way is a spiral galaxy, one of countless others in the universe, but it is ours. It is home. And like all spiral galaxies, it has a certain shape, a certain architecture that has been sculpted by gravity and time. At the center of the Milky Way is a dense, bright bulge. This is the heart of the galaxy, packed with older stars, golden and red, stars that have been burning for billions of years. Around this bulge, the spiral arms extend outward, each one a river of light flowing through the dark. These arms are not solid. They are regions where stars are born, where gas and dust gather and collapse under their own weight, igniting new suns that light up the darkness. The arms are blue and white, glowing with the fierce light of young, hot stars. And beyond the visible disk surrounding it all is the halo. This is a vast, spherical region that extends far beyond the spiral arms, filled with ancient star clusters and mysterious dark matter. The halo is the galaxy's protective shell, its invisible embrace, holding everything together. Our solar system, our sun, our Earth, all of it sits within one of these spiral arms. We live in a region called the Orion Spur, a smaller branch that connects two of the major arms. We are not at the center of the galaxy. We are not at the edge. We are somewhere in between, about 26,000 light-years from the galactic core, nestled safely in a quiet neighborhood where stars are spaced comfortably apart. And here's something truly calming to consider. The Milky Way rotates, but it rotates slowly. Our Sun, along with all the stars in our region, orbits the center of the galaxy at a speed of about 230 kilometers per second. That sounds fast, but on the scale of the galaxy, it is a gentle drift. It takes our Sun approximately 230 million years to complete one full orbit around the galactic center. This is called a cosmic year or a galactic year. Since the Sun was born about 4.5 billion years ago, it has made roughly 20 trips around the galaxy. 20 slow, patient circles, like a carousel that never stops. You are on that carousel right now. You are moving through space, carried along by the Sun, which is carried along by the spiral arm, which is carried along by the entire galaxy. And yet, you feel still. You feel at rest. Because motion on this scale is indistinguishable from stillness. The Milky Way holds you gently, the way a boat holds a sleeping passenger, rocking softly on calm water. Think about that for a moment. You are turning, right now, slowly spinning through space on a disk of stars. But you don't feel it. You feel safe. You feel held. And that's the beauty of it. In the vastness of the cosmos, we are always moving, always traveling, and yet we are always at peace. The spiral structure of the Milky Way is not permanent, you see. It's not like the arms are solid structures carved in stone. They are density waves, regions where stars and gas temporarily bunch up as they orbit the galactic center. Imagine cars on a highway, sometimes bunching up in traffic, then spreading out again. The cars move through the traffic jam, but the traffic jam itself stays in roughly the same place. That's what the spiral arms are like. Stars move into them, brighten the region with their light, then move out again. But the pattern persists. The spiral shape endures, even as individual stars come and go. This is one of the profound truths about the universe. Patterns can persist, even when their components are constantly changing. A river looks the same from day to day, but the water flowing through it is always new. A flame looks steady, but the molecules of gas feeding it are constantly being consumed and replaced. And the spiral arms of the Milky Way look permanent, but they are made of stars that are constantly orbiting, moving through the pattern, never staying in one place. We, too, are like this. The atoms in your body are constantly being replaced. You eat, you breathe, you shed skin cells, you grow new ones. The matter that makes up your body today is not the same matter that made up your body 7 years ago. And yet, you persist. Your pattern endures. You are a process, not a thing. You are a wave, not a particle. You are a constant flowing and becoming, just like the spiral arms of the galaxy. There's a deep peace in recognizing this. Nothing is permanent, and that's okay. Everything is flowing. Everything is changing. And yet patterns persist. Beauty endures. Meaning continues. The Milky Way has been spinning for billions of years, and it will continue spinning for billions more, even though the stars within it are constantly being born and dying, moving and changing. You too will continue. Not in the same form forever, but as part of the great flow of matter and energy through the cosmos. Your atoms will become other things, other beings, other patterns. But for now, in this moment, you are you. And that is enough. Now let's drift a little deeper. Let's go back in time. Not just a few years or a few centuries, but billions of years. Let time stretch out before you like soft fabric, folding back and back, further than you can imagine, to a moment when the Milky Way was young. The Milky Way is old, ancient even. It formed about 13.6 billion years ago, not long after the universe itself was born. The Big Bang happened roughly 13.8 billion years ago, and within just a few 100 million years, the first galaxies began to take shape. The Milky Way was one of them. In those early days, the galaxy was very different. It was smaller, more chaotic, filled with gas and dust, with fewer stars and no spiral structure yet. The universe itself was different then. It was denser, hotter, more violent. The first stars were massive, hundreds of times the mass of our Sun, burning bright and fast, living for only a few million years before exploding as supernovae. These first stars were made of almost pure hydrogen and helium, the simplest elements, the only elements that existed in abundance after the Big Bang. They had no planets like ours because there were no heavy elements yet to form rocky worlds. No carbon, no oxygen, no silicon, no iron. Just hydrogen and helium, the building blocks of the universe, fusing in the cores of these massive stars. When these first stars died, they scattered their contents across space. The heavier elements they had created through nuclear fusion, carbon, oxygen, neon, magnesium, silicon, iron, all of it was ejected into the surrounding gas clouds. And those gas clouds, now enriched with these new elements, collapsed to form the next generation of stars. And when those stars died, they added even more heavy elements to the mix. Generation after generation, the galaxy became more chemically diverse, more complex, more capable of forming interesting structures like planets and, eventually, life. The Milky Way grew over time, not just by forming new stars, but by consuming smaller galaxies. It merged with them, absorbed them, took their stars and gas, and incorporated them into its own structure. This is how galaxies evolve. They collide, they merge, they grow. And each collision, each merger, adds another chapter to the galaxy's long history. Even today, the Milky Way is still consuming smaller galaxies. There are dwarf galaxies orbiting our galaxy right now, slowly being torn apart by tidal forces, their stars being stripped away and absorbed into the Milky Way's halo. This process is ongoing. The galaxy is not a static structure. It is a living, growing, evolving system, constantly changing, constantly incorporating new material. Our Sun is a relative newcomer to this story. It formed about 4.5 billion years ago in a cloud of gas and dust left over from previous generations of stars. By the time the Sun was born, the Milky Way was already ancient. It had already lived through 9 billion years of history. It had already seen countless stars born and die. It had already witnessed the formation of the spiral arms, the settling of the disk, the quiet maturation of a galaxy reaching its prime. The cloud that formed our Sun was part of a larger structure, a giant molecular cloud, the kind of cold, dark nebula where stars are born. Something triggered the collapse of this cloud, perhaps the shockwave from a nearby supernova, perhaps the gravitational influence of passing stars. Whatever the cause, the cloud began to contract under its own gravity, spinning faster as it collapsed, flattening into a disk. At the center of this disk, where the matter was densest and the temperature was highest, the Sun ignited. Nuclear fusion began in its core, and it started to shine. Around the Sun, in the spinning disk of gas and dust, planets began to form. Rocky planets close in, where it was too hot for ice to exist. Gas giants farther out, where the cold allowed ice and gas to accumulate. And small, icy bodies in the outer reaches, the comets and dwarf planets, that still orbit in the distant frozen edge of the solar system. Earth formed in that disk. Our planet is made of material that was part of the Milky Way for billions of years before it became Earth. The atoms in the rocks beneath your feet were once part of a nebula drifting through space. Before that, they were part of a star fusing in a nuclear furnace. Before that, they were part of the early universe, simple hydrogen and helium, waiting to become something more. And here's the beautiful part. The light we see when we look up at the night sky, the stars that dot the darkness, much of that light has been traveling for years, sometimes centuries, sometimes thousands of years before it reaches our eyes. When you look at a star, you are seeing it not as it is now, but as it was when that light began its journey. You are looking back in time. The Milky Way itself is a kind of time machine. Every layer of it, every region, tells a story about a different era in cosmic history. The old stars in the central bulge remember the early days, when the galaxy was young and wild. The stars in the disk, like our sun, are middle-aged, formed when the galaxy had already settled into its spiral shape. And the stars being born right now in the bright blue arms are the youngest of all, infants in cosmic terms, just beginning their long lives. Some of the stars you see in the night sky have already died. Their light is still traveling toward us, still crossing the vast distances of space. But the stars themselves no longer exist. They burned out years ago, centuries ago, maybe even thousands of years ago, and we won't know until their light finally fades from our view. This is the strange nature of looking at the cosmos. We are always seeing the past. The sun we see in the sky is the sun as it was 8 minutes ago, because that's how long it takes light to travel from the sun to Earth. The nearest star, Proxima Centauri, we see as it was 4 years ago. Stars farther away we see as they were tens, hundreds, thousands of years ago. And when we look at distant galaxies through telescopes, we see them as they were millions or billions of years ago, when the universe was young and those galaxies were just beginning to form. We are latecomers to this ancient story. Humanity has existed for only a few 100,000 years, a blink of an eye compared to the age of the galaxy. Civilization, the building of cities and the writing of books and the creation of art and science, that's only been happening for a few thousand years. We have only just begun to understand the cosmos, to map the stars, to comprehend the vast scales of time and space that surround us. And yet, here we are, aware of it, conscious of it, able to look up and understand, at least in part, the vastness of the structure that holds us. We are the universe becoming aware of itself. We are stardust, contemplating stardust. We are a way for the cosmos to know itself. There is something deeply comforting in that. We are small, yes. We are brief. But we are part of something timeless. The Milky Way has been here long before us, and it will be here long after we are gone. And in the meantime, we get to witness it. We get to be here, now, drifting through its light. The galaxy does not know we exist. It does not care about our lives, our joys, our sorrows. It simply exists, turning slowly, indifferent to everything except the laws of physics that govern its motion. And yet, we are here. We are part of it. We are made of its matter, lit by its stars, held by its gravity. We belong to it, even if it does not know us. And that, in its own way, is freeing. We do not need to earn our place in the cosmos. We do not need to justify our existence or prove our worth. We are here, and that is enough. The universe does not judge. It does not keep score. It simply unfolds, slowly and patiently, according to its own rhythms, and we are part of that unfolding. Rest in that knowledge. Let it ease whatever burdens you carry. You are part of an ancient story, a story that began long before you and will continue long after. You do not need to carry the weight of the world. You do not need to solve all the problems or fix all the brokenness. You are just one small part of a vast, beautiful, ongoing process, and that is enough. Now imagine this. Picture yourself floating inside a soft, glowing mist. Not a thick fog that obscures your vision, but a gentle haze filled with tiny points of light, each one distant and faint, but together creating a luminous glow all around you. You are surrounded by stars, billions of them, stretching out in every direction. This is what it's like to live inside the Milky Way. We don't often think of it this way, but we are inside a cloud of stars. The Milky Way contains somewhere between 100 billion and 400 billion stars, depending on how you count them. That's an almost incomprehensible number. If you tried to count them, one per second, it would take you thousands of years to finish. And each one of those stars is a sun, a massive ball of burning gas, radiating light and heat into the void. Most of these stars are too far away for us to see with our naked eyes. The light from most of them is too faint, or they are hidden behind clouds of dust, or they are simply too distant. But they are there, shining quietly in the dark, each one a world unto itself, each one possibly surrounded by planets, moons, asteroids, comets. When we look up at the night sky, away from city lights, we see a band of soft, milky light stretching across the heavens. This is the Milky Way as seen from inside. We are looking edge-on into the disk of the galaxy, seeing the combined light of millions of stars too faint to distinguish individually. It's like standing inside a forest and looking out through the trees. You see the forest as a whole, a texture, a pattern, but not every individual tree. The name Milky Way comes from ancient Greek mythology. The Greeks saw this band of light and called it Galaxias Kyklos, the Milky Circle, because it looked like spilled milk across the sky. In Greek myth, the Milky Way was said to be milk from the breast of the goddess Hera, sprayed across the heavens when the infant Heracles nursed too greedily. Different cultures have different stories about this band of light. Some saw it as a river, some as a path, some as a bridge between worlds. But all of them recognized it as something special, something mysterious, something worthy of stories. It wasn't until the early 1600s that Galileo Galilei pointed his telescope at the Milky Way and discovered that it was made of stars. Countless stars, too faint to see individually with the naked eye, but visible through the telescope as distinct points of light. This was a revolutionary discovery. It meant that the universe was far larger and more complex than anyone had imagined. It meant that the stars were not all the same distance from Earth, but scattered through space at varying depths. It meant that we were part of something vast, something that extended far beyond the visible stars. Over the centuries, as telescopes improved and our understanding grew, we began to map the structure of the Milky Way. We discovered that it was a disk, not a sphere. We discovered that it had spiral arms. We discovered that it was rotating. We discovered that the sun was not at the center, as many had assumed, but off to one side, just one star among billions. This was a humbling realization. For much of history, humans believed we were at the center of everything. Earth was the center of the universe, and the sun and stars revolved around us. But as we learned more, that view collapsed. First, we discovered that Earth orbited the sun, not the other way around. Then we discovered that the sun was just one star among many. Then we discovered that those stars were organized into a galaxy, and that our sun was nowhere near the center of that galaxy. And finally, we discovered that our galaxy was just one among billions, scattered throughout the universe, none of them special, none of them central. It could have been devastating, this series of demotions. We were not the center of the universe. We were not even the center of our own galaxy. We were nowhere, really, just a small planet orbiting an average star in the outer regions of a typical spiral galaxy in a universe full of galaxies. But instead of being devastating, it's liberating. We don't have to be the center. We don't have to be special or unique or chosen. We can just be. We can exist quietly in our little corner of the cosmos. And that's enough. We don't have the weight of the universe on our shoulders. We're just passengers, travelers, drifting through space on our little world, part of something much larger than ourselves. Every star you can see with your naked eye, every single one, is part of our galactic neighborhood. They are our neighbors, relatively close by in cosmic terms, most of them within a few hundred or a few thousand light years of Earth. The brightest stars in the night sky, the ones that have names, Sirius, Betelgeuse, Rigel, Vega, Arcturus, Aldebaran, all of them are part of the Milky Way. All of them fellow travelers on this great spiral. Sirius, the brightest star in the night sky, is only 8.6 light-years away. It's a young star, much hotter and more luminous than our sun, blazing with a brilliant blue-white light. Betelgeuse, the red supergiant in the constellation Orion, is about 550 light-years away. It's one of the largest stars known, so big that if you placed it where our sun is, it would extend past the orbit of Mars. Betelgeuse is nearing the end of its life. It will explode as a supernova someday, maybe tomorrow, maybe 100,000 years from now, we don't know. But when it does, it will be visible from Earth even during the day, a new star in the sky, bright enough to cast shadows at night. These stars are not eternal. They are born, they live, they die. The Milky Way is constantly recycling its material, turning gas and dust into stars, and then, when those stars die, turning their contents back into gas and dust that will form new stars. It's a great cosmic cycle, a process that has been ongoing for billions of years and will continue for billions more. And between the stars, there is space, vast, empty space, light years of it. A light year is the distance light travels in 1 year, moving at 300,000 kilometers per second. That's about 9.5 trillion kilometers. And the average distance between stars in our region of the galaxy is about 4 or 5 light years. That means if you could somehow travel from our sun to the nearest star, Proxima Centauri, at the speed of light, it would take you 4 years to get there. And at any speed we can currently achieve, it would take tens of thousands of years. So the stars are not crowded together. They are separated by immense distances, drifting through space like islands in an ocean. And yet, from our perspective, they seem close. They seem like companions. Because in the darkness, even distant light feels near. The space between the stars is not completely empty, though. It's filled with a thin gas, mostly hydrogen, along with dust particles, tiny grains of carbon and silicon and other elements. This interstellar medium, as it's called, is incredibly tenuous. On Earth, the air you breathe contains about 10 to the power of 19 molecules per cubic centimeter. In the interstellar medium, there might be only one atom per cubic centimeter. It's a vacuum far better than anything we can create in a laboratory. And yet, over the vast distances of space, this thin gas adds up. There's enough of it spread across the galaxy to make new stars, to feed the ongoing cycle of birth and death and rebirth. In some regions, the interstellar medium clumps together, forming dense clouds where the gas is cold and thick enough to block visible light. These are the dark nebulae, the places where stars are born. If you look at images of the Milky Way, you'll see dark patches, regions where no stars are visible. Those aren't empty spaces. They're clouds of gas and dust, silhouetted against the background glow of more distant stars. Inside those clouds, hidden from view, new stars are forming right now, condensing out of the darkness, beginning their long lives. And in other regions, where massive stars have recently formed, the ultraviolet light from those stars ionizes the surrounding gas, making it glow with brilliant colors. These are the emission nebulae, the beautiful clouds of red and pink and purple that grace astronomy photographs. Places like the Orion Nebula, visible to the naked eye as a fuzzy patch in Orion's sword. That nebula is a stellar nursery, a place where dozens of new stars have been born in the last few million years and where many more are still forming. The Milky Way is not a static place. It's dynamic, alive with activity, constantly changing. Stars are being born and dying. Supernovae are exploding, sending shockwaves through the interstellar medium. Black holes are pulling in matter. Neutron stars are spinning hundreds of times per second, beaming radiation into space. The galaxy is a bustling, busy place, even if, from our perspective, it looks calm and still. There is a quietness to this realization. We live inside a cloud of stars, but it is a sparse cloud, a gentle one. The stars do not press in on us. They do not overwhelm. They simply exist, scattered across the sky, each one shining its own light, each one a distant beacon in the dark. And here's the comforting thought. We are never truly alone. Even in the deepest darkness, even in the quietest night, we are surrounded by light. It may be faint, it may be far away, but it is there. The stars are silent companions, drifting with us through the galaxy, sharing this journey through space and time. You don't have to see them to know they're there. You don't have to understand them to feel their presence. They are there, always, a constant reminder that even in darkness there is light. Even in emptiness there is company. Even in the vastness of space, we are not alone. The Milky Way holds us gently, the way a mother holds a sleeping child. It asks nothing of us. It expects nothing from us. It simply is, and we are part of it, safe and sound, drifting through the cosmos on our little world, surrounded by the soft glow of 100 billion suns. Now, let's consider something that might surprise you. Right now, as you listen to these words, you are moving. Not just the small movements of breathing or shifting your weight, but moving through space at incredible speed. And you don't feel it at all. The Earth is spinning on its axis, rotating once every 24 hours. At the equator, this means the surface is moving at about 1,600 kilometers per hour. You're standing still, but you're also spinning. Your body, the room you're in, the ground beneath you, all of it is turning, carried along by the rotation of the planet. And you feel nothing. No wind in your face, no sense of motion, because everything around you is moving at the same speed. At the same time, the Earth is orbiting the Sun. We travel around our star once every 365 days at a speed of about 107,000 kilometers per hour. Again, you don't feel this. You feel stationary. But you're flying through space, tracing a great ellipse around the Sun, carried along by the planet's momentum. The Earth is falling toward the Sun, constantly pulled by gravity, but it's also moving sideways fast enough that it keeps missing, keeps falling around the Sun instead of into it. This is what an orbit is, a continuous falling that never reaches the ground, and the Sun itself is not standing still. It, too, is moving. As we discussed earlier, the Sun orbits the center of the Milky Way, carrying the Earth and all the other planets along with it. This journey happens at about 800,000 kilometers per hour, or 230 kilometers per second. We are passengers on a solar system that is itself a passenger on a galaxy-wide carousel. The Sun is falling around the galactic center, just as the Earth is falling around the Sun, just as you are falling around the Earth's axis. Everything is falling, everything is orbiting, everything is in motion. But even that's not the whole story. The Milky Way itself is moving. It's not fixed in place in the universe. It, too, is traveling through space, gliding through the cosmic void like a great ship on an endless ocean. The Milky Way is part of a group of galaxies called the Local Group. This is a collection of more than 50 galaxies, all bound together by gravity, all orbiting around their common center of mass. The two largest galaxies in the Local Group are the Milky Way and Andromeda. The others are smaller, dwarf galaxies, satellites that orbit around the larger ones. Galaxies like the Large Magellanic Cloud and the Small Magellanic Cloud, visible from the southern hemisphere as fuzzy patches of light, are companions to the Milky Way, smaller galaxies that orbit around us, bound by gravity, part of our cosmic family. The entire Local Group is moving through space as a unit, drifting toward a massive concentration of galaxies known as the Virgo Cluster. The Virgo Cluster is about 54 million light-years away, and it contains thousands of galaxies, all bound together by gravity, all falling toward their common center. The Milky Way, along with the rest of the Local Group, is being pulled in that direction, accelerating slowly, adding to the complex dance of motion that characterizes the universe on large scales. And the Virgo Cluster itself is moving, pulled by even larger structures, superclusters and filaments, the great cosmic web that makes up the large-scale structure of the universe. On the largest scales, galaxies are not scattered randomly through space. They're organized into a web-like pattern with dense filaments of galaxies separated by vast empty voids. The Milky Way sits on one of these filaments, part of what's called the Laniakea supercluster, a structure containing about 100,000 galaxies, all moving together, all influenced by the same large-scale gravitational flows. When astronomers measure the motion of the Milky Way relative to the cosmic microwave background, the faint glow of radiation left over from the Big Bang, they find that our galaxy is moving at about 600 kilometers per second. That's over 2 million kilometers per hour. We are hurtling through space, carried along by invisible currents of gravity, swept up in the grand motion of the universe itself. And yet, you feel nothing. You feel still, because everything around you is moving with you. The Earth, the Sun, the stars, the galaxy, all of it traveling together like passengers on the same vast ship. There is no absolute reference frame, no fixed point against which to measure motion. Everything is relative. From your perspective, you are still and the universe is flowing past. From the universe's perspective, if it had one, you are moving and it is still. Both views are equally valid. Both are equally true. There is no standing still in the universe. Everything is in motion. Planets orbit stars. Stars orbit galaxies. Galaxies move through space. Even space itself is expanding, carrying the galaxies along with it. Motion is the natural state of everything that exists. Stillness is an illusion, a trick of perspective, a consequence of the fact that we are moving along with everything around us. But here's the beautiful paradox. Even though we are always moving, we can still find stillness. Even though the universe is in constant flux, constantly changing, constantly flowing, we can still experience peace. Because stillness is not the absence of motion. Stillness is the acceptance of it. It is the recognition that we are part of a great flowing river and that we are safe within it. Think of a leaf floating on a stream. The stream is moving, flowing, rushing over rocks and around bends. But the leaf is not fighting the current. It's not trying to swim upstream or hold its position. It's simply floating, carried along, resting on the surface of the water, at peace with the flow. The leaf is moving, yes, but it is also still. It is still in relation to the water, even though the water itself is moving. You are like that leaf. You are moving through space at incredible speeds, carried along by the Earth, the Sun, the galaxy, the cosmic web. But you are at rest in relation to all of it. You are still in the only way that matters. You are at peace with the motion, accepting it, flowing with it, not fighting against it. The Milky Way carries us forward. The universe carries us forward. And we don't have to do anything. We don't have to steer or navigate or choose a direction. We simply exist, and the cosmos takes care of the rest. We are passengers on a journey that began before we were born and will continue after we are gone. And that's okay. That's more than okay. That's beautiful. There is a deep comfort in that, a deep relief. We are not in control of the grand motions of the universe, and we don't need to be. We are held by something much larger than ourselves, something ancient and patient and utterly reliable. The galaxy glides through space, and we glide with it, safe and sound, resting in the arms of the cosmos. You don't have to understand how it works. You don't have to calculate the velocities or comprehend the forces. You can just trust that it's happening, that you're being carried along, that the universe knows what it's doing even if you don't. You can let go of the need to control, the need to understand, the need to make sense of everything. You can just be and let the cosmos do the rest. Breathe in, breathe out. Feel the stillness that exists within the motion. Feel the peace that comes from accepting the flow. You are exactly where you need to be, moving exactly as fast as you need to move, carried along by forces far greater than yourself. And you are safe. You are held. You are home. The motion of the galaxy is not chaotic or random. It follows precise mathematical laws, equations discovered by Newton and Einstein, refined by countless physicists over the centuries. Gravity shapes everything. It pulls matter together, creates stars and planets and galaxies. It bends space and time, creating the orbits we observe, the spirals we admire. The universe is not arbitrary. It is ordered, structured, predictable in its grand patterns, even if the details remain mysterious. And within this order, there is room for beauty. The spiral arms of the Milky Way are not just functional structures. They are aesthetically pleasing, graceful curves that appeal to something deep within us. We recognize pattern and symmetry. We find comfort in regularity, in the predictable turning of the cosmic wheel. The galaxy is not just a collection of stars. It is a work of art, created by the blind forces of physics, but no less beautiful for that. Some have called the universe a cosmic dance, and that's not a bad metaphor. Everything moves in relation to everything else, partners in an intricate choreography that spans billions of light years. The dance has been going on for nearly 14 billion years, and it will continue for trillions more. We get to witness just a brief moment of it, a single step in the endless performance. And yet, that moment is enough. We don't need to see the whole dance to appreciate its beauty. We don't need to understand every movement to feel its rhythm. We can simply be present, watching, listening, feeling the motion that carries us along. Rest in that motion. Let it soothe you. The galaxy turns, and you turn with it, held securely, moving through space at speeds you cannot feel, protected by distance and the gentle mathematics of orbital mechanics. You are safe. You have always been safe. The cosmos cradles you with invisible hands, and you can let yourself relax into that embrace. Now, let's turn our attention to the heart of the Milky Way. At the very center of our galaxy, 26,000 light-years from where we sit, there is something immense, something powerful, something that, for a long time, we could not see. At the center of the Milky Way, there is a supermassive black hole. Its name is Sagittarius A, pronounced Sagittarius A star, and it is one of the most extraordinary objects in the galaxy. It contains about 4 million times the mass of our Sun, all compressed into a region smaller than the orbit of Mercury. It is invisible, not because it is far away, but because it is a black hole. Nothing, not even light, can escape its gravitational pull once it crosses the boundary known as the event horizon. Black holes have a reputation. They are often portrayed as cosmic vacuum cleaners, devouring everything around them, pulling stars and planets into oblivion. But that's not quite accurate. Black holes are powerful, yes, but they are not indiscriminate destroyers. They don't reach out and grab things. They simply sit there, exerting gravity the same way any massive object does. If you replaced the Sun with a black hole of the same mass, the Earth would continue orbiting exactly as it does now. The gravitational pull would be the same. We wouldn't be sucked in. We'd just be orbiting a black hole instead of a star. Sagittarius A is not consuming the galaxy. In fact, it's relatively quiet. It sits at the center, surrounded by a dense cluster of stars, and it holds them in orbit. These stars, some of the fastest moving stars ever observed, whip around the black hole at incredible speeds, their orbits shaped by its immense gravity. Some of these stars complete an orbit in as little as 15 years, racing around the black hole at speeds of thousands of kilometers per second. But they don't fall in. They simply orbit the way planets orbit the Sun, the way the Sun orbits the galactic center. Astronomers have been watching these stars for decades, tracking their motions, measuring their speeds, calculating their orbits. And from those observations, they've been able to determine the mass of the black hole at the center. 4 million solar masses, give or take. It's a supermassive black hole, far more massive than the stellar mass black holes that form when individual stars collapse. But it's not the largest supermassive black hole known. Some galaxies have black holes billions of times the mass of the Sun at their centers. Sagittarius A is actually relatively modest as supermassive black holes go. The black hole is not a threat. It's a stabilizer. It's the anchor around which the inner galaxy revolves. Without it, the central region of the Milky Way would be very different, less organized, less stable. The supermassive black hole helps shape the galaxy, helps define its structure, helps hold it all together. This is true for most galaxies. Nearly every large galaxy has a supermassive black hole at its center. They are not aberrations or anomalies. They are integral parts of galactic structure, woven into the fabric of how galaxies form and evolve. There seems to be a relationship between the mass of a galaxy's central black hole and the properties of the galaxy as a whole. Larger galaxies tend to have more massive black holes. The black hole and the galaxy grow together, influencing each other, shaping each other over billions of years. We don't fully understand this relationship yet. We don't know exactly how supermassive black holes form, whether they grow from smaller black holes that merge together, or whether they form directly from collapsing gas clouds in the early universe. We don't know all the ways they influence their host galaxies, though we know they can have dramatic effects. In some galaxies, the black hole is actively feeding, pulling in gas and dust from its surroundings, heating that material to millions of degrees, causing it to glow brightly and shoot jets of particles out into space at nearly the speed of light. These active galactic nuclei, as they're called, can be so bright that they outshine the entire galaxy, visible from billions of light years away. But Sagittarius A is not currently active. It's quiet, dormant, not feeding on much material. Occasionally, a star or a cloud of gas wanders too close and gets pulled in, and when that happens, the black hole flares briefly, emitting X-rays and radio waves. But most of the time, it's just sitting there, invisible, holding the center. And here's the thing. We are safe. We orbit at a great distance from Sagittarius A. Even if we were somehow transported to the center of the galaxy, even if we were in orbit around the black hole, we would not be pulled in unless we crossed the event horizon. And the event horizon of Sagittarius A is only about 12 million kilometers across. That's tiny compared to the scale of the galaxy. That's about 17 times the diameter of the Sun. In cosmic terms, it's a pinpoint. From where we are, 26,000 light-years away, the black hole has no more influence on us than any other massive object at that distance. It does not pull on us. It does not threaten us. It simply exists, doing its job, holding the center, anchoring the galaxy. There is something deeply reassuring about this. Even in the dark, even at the heart of the galaxy where light cannot escape, there is balance. There is order. The black hole is not chaos. It is structure. It is the axis around which everything turns. It is the still point at the center of the spinning wheel. In many spiritual traditions, there is a concept of a center, a still point, a place of absolute calm around which everything else revolves. In meditation, we seek that center within ourselves, that place of inner stillness that remains unchanged even as thoughts and emotions swirl around it. The supermassive black hole at the center of the Milky Way is, in a way, the physical embodiment of that concept. It is the still point, the anchor, the axis. It does not move. It does not change. It simply is, and everything else orbits around it. Mystery can coexist with safety. We don't fully understand black holes. There is much we still don't know about how they work, what happens at their centers, what lies beyond the event horizon. The mathematics of black holes predicts a singularity at the center, a point of infinite density where the laws of physics as we know them break down. But we can't see that singularity. We can't probe it directly. It's hidden behind the event horizon, forever out of reach. And that's okay. Some things are meant to remain unknown, at least for now. The universe is full of mysteries, and that's part of its beauty. We don't need to understand everything to feel secure. We don't need to have all the answers to feel at peace. We can accept that there are things beyond our comprehension, things that will remain mysterious, and we can be okay with that. The Milky Way has a dark heart, but it is not a dangerous heart. It is a quiet center, a still point around which the galaxy spins. And we, out here in our spiral arm, are safe and sound, held in place by the same gravity that holds everything else. The black hole is not our enemy. It is our anchor. It is the foundation upon which the galaxy is built. And it will be there, steady and unchanging, long after we are gone. Think of it this way. The black hole at the center is like the eye of a hurricane. In a hurricane, the outer regions are violent, chaotic, full of wind and rain and destruction. But at the very center, there is calm. The eye of the storm is a place of stillness, a region where the wind drops to nothing and the sky may even be clear. The black hole is like that. It sits at the center, unmoved, while the galaxy swirls around it. And we are far from the center. We are in the quiet suburbs of the galaxy, where the motion is gentle, where the dangers are minimal, where life can exist and evolve and contemplate the cosmos. We are in the safest possible place, far from the galactic center, far from the violent regions where stars are densely packed and collisions are more common, far from the active regions where supernovae explode with alarming frequency. The Milky Way has placed us, or rather, we have found ourselves, in an ideal location. Not too close to the center, not too far from it. In a region where the elements necessary for life are abundant, where the radiation environment is benign, where the orbital dynamics are stable. We are in the Goldilocks zone of the galaxy, and that is no accident. Life arises where conditions allow it, and those conditions are most favorable here, in the gentle spiral arms, far from the chaos of the center. So rest easy, knowing that the galaxy holds you safely. The black hole at the center is not a threat. It is a guardian, a keeper of order, a silent presence that maintains the structure of our cosmic home. It asks nothing of you. It expects nothing. It simply exists, doing its work, holding the galaxy together, allowing stars like our sun to orbit in peace. Imagine now that you could somehow see beyond the visible, beyond the stars you can count, beyond the planets we have discovered, and glimpse the true scale of worlds within the Milky Way. Imagine countless planets drifting quietly in the dark, each one circling its own sun, each one a unique world with its own history, its own landscape, its own story. The Milky Way is full of planets, billions of them. For most of human history, we could only guess at this. We knew our own solar system had planets, but we had no way of knowing if other stars had them too. It seemed likely, given that the sun had planets, but we had no proof. We couldn't see planets around other stars. They were too small, too faint, too close to their parent stars to be visible with our telescopes. It was only in the early 1990s that astronomers first detected planets orbiting other stars, worlds we now call exoplanets. The first confirmed exoplanet around a Sun-like star was discovered in 1995, orbiting a star called 51 Pegasi. It was a strange world, a gas giant larger than Jupiter, orbiting incredibly close to its star, completing an orbit in just 4 days. It was nothing like the planets in our solar system, and its existence challenged our understanding of how planetary systems form. Since then, we've discovered thousands of exoplanets. Thanks to space telescopes like Kepler and TESS, which stare at patches of sky for months or years, watching for the tiny dips in starlight that occur when a planet passes in front of its star, we've been able to detect planets around stars throughout the Milky Way. And what we've found is astonishing. Planets are everywhere. Almost every star in the galaxy has at least one planet. Some have many. The Milky Way contains, conservatively, at least 100 billion planets, and possibly several hundred billion, depending on how you count them and how you define a planet. That's more planets than stars. For every sun you see in the night sky, there are multiple worlds circling it, invisible to our eyes, but nonetheless real, solid, present. These planets come in incredible variety. There are small rocky planets like Earth, some smaller than Mars, some larger than Earth, worlds we call super-Earths. There are gas giants like Jupiter and Saturn, massive worlds made mostly of hydrogen and helium, with no solid surface to stand on. There are ice giants like Uranus and Neptune, made of water, methane and ammonia ices surrounding a rocky core. There are planets that orbit so close to their stars that their surfaces are molten lava, heated to thousands of degrees. There are planets that orbit so far from their stars that they are frozen solid, colder than the coldest places on Earth. There are planets with thick atmospheres, planets with thin atmospheres, planets with no atmospheres at all, their gases stripped away by stellar winds or never captured in the first place. There are planets that orbit in the habitable zone, where liquid water could exist on the surface. There are planets that are tidally locked to their stars, always showing the same face to the sun, with one side in perpetual day and the other in perpetual night. There are planets in systems with multiple stars, where the sky might have 2 or 3 suns rising and setting at different times, casting multiple shadows, creating complex patterns of light and dark. And many of these planets are in what astronomers call the habitable zone, the region around a star where conditions might be just right for liquid water to exist on the surface. Water is essential for life as we know it, so the habitable zone is often called the Goldilocks zone. Not too hot, not too cold, but just right. The Earth sits in the Sun's habitable zone. Venus is too close, too hot. Mars is too far, too cold, though it may have been more hospitable in the past when it had a thicker atmosphere and liquid water on its surface. How many planets in the Milky Way are in the habitable zone? We don't know exactly, but estimates suggest there could be billions. Recent surveys indicate that roughly 20 to 50% of Sun-like stars have planets in their habitable zones. If we extend that to all stars in the galaxy, including red dwarfs, which are much more common than Sun-like stars, the numbers become staggering. There could be tens of billions of potentially habitable planets in the Milky Way alone. We have not found life beyond Earth. Not yet. Despite decades of searching, listening for radio signals, analyzing the atmospheres of exoplanets for signs of biological activity, we have not detected any definitive evidence of extraterrestrial life. This could mean that life is rare, it could mean that life is common, but intelligent life capable of sending signals is rare. It could mean that we're not looking in the right places or in the right ways. Or it could mean that we're alone, the only living things in the entire galaxy. We don't know. And that uncertainty is both sobering and thrilling. The question of whether we are alone in the universe is one of the oldest and most profound questions humanity has ever asked. And we are, right now, in the process of answering it. Every new planet discovered, every new star surveyed, every new technique developed to detect biosignatures in distant atmospheres brings us closer to an answer. But the sheer number of possibilities is staggering. The Milky Way is not a barren place. It is full of potential, full of worlds waiting to be discovered, full of environments that might, right now, be home to living things. Maybe simple life, single-celled organisms clinging to existence in subsurface oceans or deep underground. Maybe complex life, ecosystems of strange and wonderful creatures adapted to environments we can barely imagine. Maybe intelligent life, civilizations looking up at their own night skies and wondering if they are alone. And it's not just planets. The galaxy is full of moons too. Some of them are small and dead, bare rocks with no atmosphere, no water, no interesting chemistry. But others are fascinating worlds in their own right. In our own solar system, moons like Europa, one of Jupiter's 4 large moons, and Enceladus, a small moon of Saturn, have subsurface oceans, kept liquid by tidal heating, as the moons are squeezed and stretched by the gravitational pull of their parent planets. Europa's ocean is hidden beneath a thick shell of ice, perhaps 10 to 15 kilometers thick. But beneath that ice, there may be more water than in all the oceans on Earth combined. And where there is liquid water, especially liquid water that has existed for billions of years, there might be life. The water on Europa is in contact with a rocky seafloor, which means there could be hydrothermal vents, underwater volcanoes that spew hot, mineral-rich water into the ocean, creating chemical energy that life could use. On Earth, hydrothermal vents support entire ecosystems in the deep ocean, places where sunlight never reaches, but life thrives nonetheless. Enceladus is even more intriguing. This small moon, only about 500 kilometers across, has geysers erupting from its south pole, shooting plumes of water ice and organic molecules into space. These plumes come from a subsurface ocean, and they contain the ingredients necessary for life as we know it. Water, organic compounds, energy. The Cassini spacecraft flew through these plumes multiple times before its mission ended, analyzing their composition, and it found complex organic molecules, the building blocks of life. We don't know if there is life on Europa or Enceladus. We don't know if there is life anywhere beyond Earth. But the possibilities are tantalizing. And if there is life in the subsurface oceans of moons, in our own solar system, then similar oceans around other stars might also harbor life. The Milky Way might be teeming with life in places we would never have thought to look, hidden beneath the ice, shielded from the harsh radiation of space, quietly existing in the dark. Beyond planets and moons, the galaxy is full of other objects as well. Asteroids, rocky bodies ranging in size from boulders to hundreds of kilometers across, leftovers from the formation of planetary systems, drifting through space in vast belts or wandering alone. Comets, icy bodies from the outer reaches of star systems, occasionally falling inward toward their stars, heating up, releasing gas and dust that forms a glowing tail visible from millions of kilometers away. Clouds of gas and dust, the raw material from which stars and planets form, spread across the galaxy in vast, cold nebulae. Stellar nurseries where new stars are being born, glowing brightly with the heat of formation. Planetary nebulae where old stars are dying, puffing off their outer layers in beautiful, colourful shells. Supernova remnants where stars have exploded and scattered their contents across space, seeding the interstellar medium with heavy elements. The Milky Way is not empty. It is a vast, complex ecosystem, a web of interconnected systems and cycles, all playing out over billions of years. Stars are born from gas and dust. They live for millions or billions of years. They die and return their material to space, and that material forms new stars. Planets form around stars. They evolve over time. They may harbor life. They are eventually destroyed when their stars die, or when their orbits are disrupted. Everything is connected. Everything is part of the cycle. We have only just begun to explore it. We have only just started to catalogue the worlds around nearby stars. We've discovered thousands of exoplanets, but that's just a tiny fraction of the total. Most of the planets in the Milky Way remain unknown, invisible to our telescopes, waiting to be found. And with each new discovery, we learn something new about how planetary systems form, how common different types of planets are, how varied the conditions in the galaxy can be. There is so much we don't know, so much we haven't seen. But every discovery adds to the picture. Every new planet detected adds another piece to the puzzle. We are living in the early days of a revolution in astronomy, a time when we are transitioning from knowing only our own solar system to mapping the planets of the entire galaxy. Future generations will look back on this time as the era when humanity first discovered that we are not alone in having a planetary system, that the cosmos is full of worlds, that the Milky Way is richer and more complex than we ever imagined. And here's the comforting thought. We are not the only world. The Milky Way is alive with possibility. Somewhere out there, orbiting a distant star, there might be another planet, another place where the conditions are right, where life has taken hold, where beings of some kind, whatever they might be, are looking up at their own night sky and wondering if they are alone. We don't know if that's true. We may never know. The distances are so vast, the galaxy so large, that even if intelligent life exists elsewhere, we might never be able to communicate with it. The nearest potentially habitable planet might be dozens or hundreds of light years away. A radio signal sent from there would take decades or centuries to reach us, and our reply would take just as long to reach them. And that's assuming they're using radio waves, assuming they're trying to communicate, assuming they exist at all. But the possibility is there, and it is beautiful. The universe is vast, and we are small, but we are not necessarily unique. The galaxy is full of worlds, full of chances, full of opportunities for something extraordinary to happen. Life might be rare, but it might not be singular. We might be one among many, part of a vast community of living worlds spread across the Milky Way, most of them unaware of each other, most of them too far apart to ever meet, but all of them part of the same cosmic story. And even if we are alone, even if Earth is the only world with life, that is extraordinary too. It means we are precious. It means we are rare. It means this little blue planet, this quiet corner of the galaxy, is something special, something worth protecting, something worth cherishing. We are the universe's way of knowing itself. We are the cosmos becoming aware. And that, whether we are alone or one among many, is a profound and beautiful thing. Either way, the Milky Way is full of wonder. It is full of worlds we have not yet seen, stories we have not yet heard, mysteries we have not yet solved. And we get to be here, now, at the beginning of the age of discovery, when humanity is just starting to reach out and explore the cosmos, when we are just beginning to understand the vast richness of our galactic home. Picture, if you will, a planet orbiting a red dwarf star, a star much smaller and cooler than our Sun. Red dwarfs are the most common type of star in the galaxy, making up about 70% of all stars. They burn slowly, efficiently, living for trillions of years, far longer than the current age of the universe. A planet in the habitable zone of a red dwarf would orbit very close to its star, perhaps completing an orbit in just a few days or weeks. It would likely be tidally locked, one side always facing the star, baked in perpetual daylight, the other side frozen in perpetual night. But at the boundary between day and night, the terminator line, conditions might be just right. Not too hot, not too cold. And there, perhaps, life could exist. Strange life, adapted to the constant twilight, to the red light of its sun, to the eternal winds that blow from the hot side to the cold side. Life that has never known a sunrise or a sunset, because the sun never moves in its sky. Life that is utterly alien to us, and yet, in its essence, perhaps not so different. Life that grows, reproduces, evolves, adapts. Life that is part of the same cosmic story we are part of. Or imagine a world orbiting a binary star system, two suns locked in an eternal dance, circling each other every few days or weeks. The planet would experience complex lighting patterns, with both suns sometimes visible in the sky, sometimes only one, sometimes neither, as one eclipses the other. The seasons would be irregular, chaotic, dictated not by axial tilt, but by the changing geometry of the three-body system. And yet, life might adapt. Life is resilient. It finds a way if conditions allow. Or imagine a moon, like Europa or Enceladus, but orbiting a gas giant in the habitable zone of a sun-like star. The moon would have two sources of energy, the heat from its star and the tidal heating from its planet. Its surface might be covered in ice, but beneath that ice, a vast ocean, warmed by tidal forces, possibly harboring life in its dark depths. And in its sky, dominating the view, would be its parent planet, a massive gas giant showing its face, in ever-changing phases, a constant companion, a reminder that this moon is not alone. These are just a few of the possibilities. The Milky Way is full of environments we haven't imagined, conditions we haven't considered, configurations we haven't encountered. Every new planet discovered teaches us something new about what's possible, about how varied planetary systems can be, about how many different ways nature can arrange matter and energy. And this variety is comforting, in a way. It means the universe is not boring. It means there is always more to discover, always new wonders to find, always surprises waiting. The cosmos is not a simple, predictable place. It is rich, complex, endlessly creative. And we are part of that creativity, participants in the grand experiment of existence. Now, let's talk about something truly poetic, something that connects you personally to the stars themselves. You are made of stardust, not metaphorically, not symbolically, but literally. The atoms in your body, the elements that make up your bones and blood and breath, were forged inside stars that lived and died long before the sun was born. In the beginning, just after the Big Bang, the universe was simple. It contained only the lightest elements, hydrogen and helium, with traces of lithium. That was it. No carbon, no oxygen, no iron, no nitrogen, no phosphorus, no sulfur. None of the elements that make up planets or water or living things. Just hydrogen and helium, the simplest atoms, created in the first few minutes after the universe began. For hundreds of millions of years, that's all there was. The universe expanded and cooled, and eventually gravity began to pull the hydrogen and helium together into the first stars. These first stars were massive, hundreds of times the mass of our sun, burning bright and fast, living for only a few million years before exploding as supernovae. Stars are nuclear furnaces. In their cores, the temperature and pressure are so extreme that atomic nuclei can fuse together, combining to form heavier elements. In the core of a star like the Sun, hydrogen atoms fuse together to form helium, releasing energy in the process. This is what makes stars shine. This is what powers them, what keeps them from collapsing under their own gravity. But as a star ages, as it runs out of hydrogen in its core, it starts fusing helium into heavier elements. Helium fuses to form carbon and oxygen. Carbon fuses to form neon and magnesium. Oxygen fuses to form silicon and sulfur. Silicon fuses to form iron. Each step of fusion releases less energy, and each step requires higher temperatures and pressures. The star is fighting a losing battle against gravity, building up layers of heavier and heavier elements in its core, like an onion, with iron at the very center. For the most massive stars, this process continues until the core is made of iron. And then the fusion stops. Iron is the most stable element. Fusing iron into heavier elements doesn't release energy. It requires energy, which means the core can no longer support itself. Gravity wins. The core collapses in a fraction of a second, shrinking from the size of a planet to the size of a city, becoming a neutron star, or, if the star is massive enough, a black hole. The collapse releases an enormous amount of energy, and the outer layers of the star rebound, exploding outward in a supernova. For a few weeks, a single exploding star can shine as brightly as an entire galaxy, releasing more energy in those few weeks than the sun will release in its entire lifetime. And in that explosion, in the intense heat and pressure of the blast, even heavier elements are created. Gold, silver, platinum, uranium. All the elements heavier than iron are made in supernovae, in those brief cataclysmic moments when a star dies. The explosion scatters these elements across space. They mix with clouds of gas and dust, enriching them, adding new ingredients to the cosmic recipe. And later, when those clouds collapse to form new stars and planets, those elements are incorporated into the new generation. This is how the universe became chemically diverse. This is how the elements necessary for planets and life came into existence, through the deaths of stars. Our sun is a third-generation star, or possibly fourth. It formed from a cloud of gas and dust that was already enriched with heavy elements from previous generations of stars. The planets of our solar system, including Earth, formed from the leftover material around the young sun, and they too are made of stardust. The rocks beneath your feet, the water in the oceans, the air you breathe, all of it is made from atoms that were created inside stars that exploded billions of years ago. Everything on Earth, the rocks, the oceans, the air, the trees, the animals, and you, all of it is made from atoms that were forged in the nuclear furnaces of ancient stars. The carbon in your cells, the same carbon that forms the backbone of every organic molecule, every protein, every strand of DNA, was created by helium fusion in the core of a red giant star. The oxygen you breathe, the oxygen that makes up a large fraction of your body weight, was created by carbon fusion. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, all of it was created in stars and scattered across space when those stars died. You are not separate from the cosmos. You are part of it. You are made of the same stuff as the stars. You are recycled stardust, given form and breath and consciousness. You are the universe experiencing itself, looking back at itself, trying to understand itself. There is something profoundly comforting in this. We are not strangers in the universe. We are not aliens dropped into a foreign place. We are children of the cosmos. We belong here. Our atoms have been on a journey that spans billions of years, from the cores of ancient stars through the cold of interstellar space, into the swirling disk of gas that became our solar system, into the planet Earth, and eventually into you. Every breath you take contains atoms that were once inside a star. Every heartbeat is powered by energy that can be traced back, step by step, to nuclear fusion in the sun, which itself is a continuation of the processes that have been happening in stars since the first generation ignited billions of years ago. The iron in your blood, the same iron that carries oxygen to your cells, that keeps you alive, was forged in the core of a massive star in the final moments before it exploded as a supernova. That iron was scattered across space, drifted through the interstellar medium for millions or billions of years, eventually becoming part of the cloud that formed the sun and the planets, and finally, billions of years later, becoming part of you. You are carrying around inside you the remnants of exploded stars. You are made of pieces of the universe that have been recycled over and over through countless generations of stars, through the formation and destruction of countless worlds. Your atoms are ancient. They are older than the Earth, older than the Sun, almost as old as the universe itself. And they will continue long after you are gone, returning to the Earth, eventually being recycled again into new forms, new beings, new stories. We are connected to everything. The stars above are not distant, unrelated objects. They are our ancestors. They are the forges where our atoms were made. The light they send us is not just illumination. It is a reminder of where we came from, a message from the past, a connection across time and space. When you look at your hand, you are looking at stardust. When you breathe, you are inhaling atoms that were once part of a nebula floating between the stars. When your heart beats, it beats with energy that ultimately comes from nuclear fusion, the same process that powers the stars. You are not just in the universe. You are part of the universe. You are the universe, looking at itself, experiencing itself, becoming aware of itself. And when you look up at the night sky, when you see the Milky Way stretching across the darkness, you are not looking at something separate. You are looking at family. You are looking at the place where your atoms were born. You are looking at the cosmic cauldron from which everything you are made emerged. You are looking at home. This is the poetry of cosmology. This is the wonder of science. We are stardust, contemplating stardust. We are the cosmos, waking up and becoming aware. We are the universe's way of knowing itself. And that is one of the most beautiful realizations a human being can have. You are made of light. You are made of the material of stars. You are ancient and new at the same time. Your body is temporary, but your atoms are eternal. You are a brief pattern in the flow of matter and energy through the cosmos. But you are a meaningful pattern, a conscious pattern, a pattern that can look back at the stars and understand, at least in part, where it came from. There is a deep peace in accepting this. You are part of something much larger than yourself. You are not isolated. You are not separate. You are woven into the fabric of the universe, connected to everything through the atoms you are made of, through the light that reaches your eyes, through the gravity that holds you to the earth, and the earth to the sun, and the sun to the galaxy. You belong here. You are home. And the stars, the distant suns scattered across the Milky Way, are not strangers. They are kin. They are the ancestors of your atoms. They are the reason you exist. Think about the journey your atoms have taken. Billions of years ago, they were part of a massive star, fusing in the intense heat of its core, building up heavier and heavier elements. Then, in a moment of spectacular violence, that star exploded, scattering your atoms across space. They drifted for millions of years through the cold, dark expanse between stars, part of the interstellar medium, slowly being incorporated into a new cloud of gas and dust. That cloud, over time, began to collapse under its own gravity. It spun faster, flattened into a disk, and at its center, a new star ignited. Our sun. And in the disk around the sun, small grains of dust began to stick together, growing larger, attracting more material through gravity, eventually forming rocky planets. One of those planets was Earth. Your atoms became part of Earth. They were part of the molten rock that made up the early planet, part of the volcanic outgassing that created the atmosphere, part of the oceans that condensed from water vapor. They cycled through the Earth's systems for billions of years, part of rocks that were weathered into soil, part of minerals that dissolved in water, part of the chemical reactions that gave rise to life. They became part of living things, simple, single-celled organisms at first, then more complex creatures as life evolved. They were part of the first plants, using sunlight to convert carbon dioxide into sugars. They were part of the first animals, consuming those plants, building bodies, reproducing, dying, returning their atoms to the earth. Generation after generation, your atoms cycled through life and death and life again, part of countless organisms over billions of years. And then, recently, in the grand sweep of cosmic time, they became part of you. The food you eat, the water you drink, the air you breathe, all of it is incorporated into your body, becoming part of your cells, part of your bones and muscles and organs. You are built from the Earth, which is built from the solar system, which is built from the galaxy, which is built from the universe. You are a temporary arrangement of ancient atoms, a brief pattern that will exist for a few decades and then dissolve, the atoms returning to the Earth, eventually to be part of other things, other beings, other stories. But for now, in this moment, they are you. They are organized into the specific structure that is your body, your mind, your consciousness. They are experiencing the universe from this particular perspective, this unique point of view that is yours alone. And that is extraordinary. That is miraculous. Out of all the possible arrangements of atoms, out of all the possible configurations of matter and energy, the universe has created you. You are a way for the cosmos to know itself, to experience itself, to appreciate its own beauty. You are the universe, briefly conscious, briefly aware, briefly able to look back at the stars and understand the connection. This realization should not make you feel small or insignificant. It should make you feel connected, part of something vast and ancient and beautiful. You are not separate from the universe. You are not an observer standing outside, looking in. You are a participant, a part of the whole, the expression of the cosmos itself. And when this life ends, when your atoms disperse and return to the earth, they will continue their journey. They will become part of the soil, part of plants, part of animals, part of the air and water. They will cycle through the Earth's systems for millions of years more, until eventually, perhaps, the sun dies and the Earth is destroyed, and your atoms are scattered back into space to become part of new stars, new planets, new worlds, new possibilities. The journey never ends. The atoms are eternal. They persist through all changes, all transformations, all cycles of birth and death and rebirth. And right now, in this moment, they are you. They are experiencing this moment, this breath, this heartbeat, this thought. They are the universe becoming aware of itself through you. Rest in that knowledge. You are stardust, briefly gathered into human form, experiencing the cosmos. You are ancient and temporary at the same time. You are eternal and fleeting. You are a small part of something vast, and yet, in this moment, you are everything. You are the center of your own experience, the lens through which the universe observes itself. You are enough. You are exactly enough. You are perfect in this moment, exactly as you are. And the stars, the distant suns that forged the atoms of your body, shine on, indifferent but not hostile, distant but not unconnected. You are part of them, and they are part of you. And together, you are all part of the great cosmic dance that has been unfolding for billions of years, and will continue for billions more. Finally, let's look forward. Let's imagine the far future, billions of years from now, when the Milky Way will be very different from the way it is today. Because galaxies, like stars, like planets, like everything in the universe, change over time. They evolve, they grow, and sometimes they merge. In about 4.5 billion years, the Milky Way will collide with the Andromeda galaxy. Andromeda is our nearest large galactic neighbor. It's about 2.5 million light-years away, which sounds like a lot, but on the scale of the universe, it's practically next door. Andromeda is slightly larger than the Milky Way, containing about 1 trillion stars compared to our few 100 billion. It's a beautiful spiral galaxy, much like our own, with graceful arms and a bright central bulge. And it is moving toward us, pulled by gravity, approaching at about 110 kilometers per second. Right now, if you know where to look, you can see Andromeda with your naked eye. On a dark, clear night, away from city lights, it appears as a faint, fuzzy patch of light in the constellation Andromeda, near the great square of Pegasus. It's the most distant object you can see without a telescope, a galaxy of 1 trillion stars visible as a smudge of light. And it's coming closer. Every second, Andromeda moves 110 kilometers closer to the Milky Way. That might not sound like much, but over millions of years it adds up. The two galaxies are on a collision course, drawn together by the invisible force of gravity, falling toward each other through the void. In a few billion years, Andromeda will loom large in our night sky. It will no longer be a faint smudge, but a bright, sprawling structure dominating the heavens. Its spiral arms will be visible even to the naked eye, stretching across the sky like great rivers of light. It will be a spectacular sight, a reminder that the universe is not static, that everything is moving, that change is inevitable even on the largest scales. And then the two galaxies will collide. But this is not the violent, destructive collision that the word might suggest. Galaxies are mostly empty space. The stars within them are separated by vast distances, light years of emptiness between them. When the Milky Way and Andromeda merge, the stars will not crash into each other. The chances of any two stars actually colliding are astronomically small. They will pass by each other like ships in the night, their paths altered by gravity, but most of them unharmed. What will happen is a slow, graceful dance. The two galaxies will pass through each other, their shapes distorted by tidal forces, the gravitational pull of one galaxy stretching and warping the other. They will stretch and warp, pulling long streams of stars out into space, creating tidal tails that extend for hundreds of thousands of light years. Then they will swing around and pass through each other again and again. Over hundreds of millions of years, the two galaxies will spiral closer and closer, losing energy through gravitational interactions, until finally they merge into a single, larger galaxy. Astronomers have already given this future galaxy a name: Milky, a blend of Milky Way and Andromeda. It will likely be an elliptical galaxy, a fuzzy, football-shaped cloud of stars, lacking the elegant spiral structure of its parent galaxies. Elliptical galaxies form when spiral galaxies merge, their ordered structures disrupted by the collision, their spiral arms torn apart and scattered. But it will be home. It will be the new cosmic structure that contains our Sun, if our Sun is still around. And that's an important point. By the time the merger is complete, about 5 to 7 billion years from now, our Sun will be nearing the end of its life. The Sun is currently about halfway through its main sequence lifetime, the phase where it fuses hydrogen into helium in its core. In about 5 billion years, the hydrogen in the core will be exhausted and the Sun will begin to change. It will swell into a red giant, expanding to hundreds of times its current size, growing so large that it will engulf the inner planets. Mercury will be consumed. Venus will be consumed. Earth might be consumed as well, or it might survive, orbiting just beyond the Sun's outer layers, scorched and lifeless, baked by the intense heat of the dying star. Life on Earth, if it still exists at that time, will long since have had to find a new home. As the Sun ages, it is gradually getting hotter, and in about 1 billion years, the Earth will become too hot for life as we know it. The oceans will evaporate, the atmosphere will be stripped away, the planet will become a barren, lifeless rock, much like Venus is today. Any civilization that survives that long will have to leave Earth, colonize other worlds, spread out among the stars, or perish. Humanity, if it still exists in any recognizable form, billions of years from now, will likely have spread throughout the galaxy, or evolved into something we cannot currently imagine, or gone extinct long ago. The timescales involved are so vast that trying to predict what humanity will be like billions of years in the future is essentially meaningless. We are talking about time spans longer than the entire history of complex life on Earth. Anything could happen. Everything will change. So the merger of the Milky Way and Andromeda will not affect us, not directly. But it will be a spectacular event for any beings who are around to witness it. The night sky will change. The constellations we know will be scrambled, their patterns lost as stars are flung into new orbits. New constellations will form. The structure of the galaxy will be transformed. The view of the cosmos from any surviving worlds will be completely different. For those who witness it, assuming anyone is around to do so, it will be a reminder of the impermanence of all things, even galaxies. The Milky Way, which has existed for 13 billion years, which has been the stage for countless stellar births and deaths, which has been home to our Sun and our Earth for 4.5 billion years, will cease to exist as a distinct entity. It will become part of something new. And here's the beautiful part. This is not an ending. It's a transformation. Galaxies do not die when they merge. They become something new. The stars continue to shine. New stars are born from the clouds of gas and dust stirred up by the collision, the merger triggering waves of star formation as gas clouds are compressed and collapse. Planets continue to orbit. Life, wherever it exists, continues. Change is part of the cosmic rhythm. Nothing lasts forever, and that's okay. Everything in the universe is temporary. Stars are born and die. Planets form and are destroyed. Galaxies merge and evolve. Even the universe itself had a beginning, and it will have an ending, though what that ending looks like is still a matter of debate among cosmologists. But endings are also beginnings. When a star dies in a supernova, it scatters the elements necessary for new stars and planets. When galaxies merge, they create new structures, new configurations, new opportunities for stars to form. The universe is constantly recycling itself, breaking down old structures and building new ones from the pieces. The Milky Way, as we know it, will one day be gone, absorbed into Milky. But that structure will carry forward the legacy of the Milky Way, all the stars, all the planets, all the history, all the stories. The stars that shone in the Milky Way will shine in Milky. The atoms that were part of planets orbiting those stars will continue to exist, perhaps as part of new planets in the new galaxy. Nothing is lost. Not really. It's all just transformed. And that's true for you as well. You are temporary, but the atoms you are made of are not. They have existed since the early universe, and they will continue to exist long after you are gone. They will be recycled, returned to the Earth, eventually dispersed back into space, incorporated into new stars, new planets, new beings. You are a temporary pattern in the flow of matter and energy through the cosmos. But the matter and energy themselves are eternal. They persist. They change form, but they never cease to exist. In the grand story of the universe, endings and beginnings blend together. What looks like an ending from one perspective is a beginning from another. The merger of the Milky Way and Andromeda is the death of two galaxies and the birth of one new one. It is loss and creation happening at the same time. It is transformation, the fundamental process that drives everything in the universe. And we are part of that story. Our atoms, the atoms that make up our bodies right now, will still exist billions of years from now. They will have been recycled, reformed, perhaps incorporated into new planets orbiting stars in Milky. perhaps part of new beings, new forms of life we cannot imagine. We are not permanent, but we are persistent. We are part of the great flow, the endless cycling of matter and energy through the cosmos. There is a deep peace in accepting this. We are part of something much larger than ourselves, something that will continue long after we are gone. The universe does not need us to exist, but we are here anyway, and we get to experience it, to witness it, to be part of the great unfolding. We are temporary, but we are meaningful. Our lives, brief as they are, have value. The things we create, the love we share, the beauty we appreciate, the understanding we develop, all of it matters, even though it won't last forever. Maybe especially because it won't last forever. The temporary nature of things makes them precious. The Milky Way will merge with Andromeda, the Sun will die, the Earth will be destroyed. The universe will continue its slow evolution toward heat death, the eventual state where all energy is evenly distributed, all stars have burned out, all black holes have evaporated, and nothing interesting can happen anymore. That's the ultimate fate of the universe, as far as we understand it, trillions upon trillions of years in the future. A cold, dark, empty void. But that's so far in the future that it's essentially irrelevant. In the meantime, we have now. We have this moment, this brief flicker of consciousness in the vastness of time and space. We have the stars above us, shining in the night. We have the Milky Way, turning slowly, holding us in its arms. We have each other, fellow travelers on this journey through the cosmos. And that is enough. That is more than enough. That is everything. Imagine what it will look like, that future sky. Two galaxies interpenetrating, stars from both mingling, creating patterns we cannot predict. The gas clouds will collide, compressing, triggering bursts of star formation. Millions of new stars will be born, hot, blue, brilliant, lighting up the merged galaxy with fresh light. It will be a time of chaos and creation, destruction and renewal, all happening at once. And perhaps, somewhere in that newly formed galaxy, on a planet orbiting a star that hasn't even been born yet, there will be beings looking up at their sky, witnessing the aftermath of the merger, studying the history of their galaxy, discovering that it was once two separate galaxies that came together billions of years earlier. Perhaps they will find remnants of our sun, an old white dwarf, cooled and dark, drifting through space, carrying with it the story of the planets that once orbited it, including one blue world where life arose and flourished and eventually spread to the stars. Or perhaps not. Perhaps our sun will be lost in the chaos, indistinguishable from the trillion other stars, its story forgotten, its planets long since destroyed. But the atoms will persist. The elements forged in the sun's core during its long life, the elements that were once part of Earth, that were once part of you, will still be there, scattered through the galaxy, waiting to become part of something new. This is the legacy we leave, not in monuments or achievements, but in the simple persistence of matter and energy, cycling through the cosmos, forever changing, forever becoming something else. We are part of that cycle, and that is our immortality, not as individuals, but as participants in the great flow. And now, as we come to the end of our journey, let's return to where we started, here, now. In this quiet moment, wherever you are, you have drifted with me through the Milky Way. You have traveled back in time to the galaxy's birth, watching it grow from a small, chaotic cloud of gas into the majestic spiral it is today. You have floated inside a cloud of stars, surrounded by billions of distant suns, each one shining its own light into the darkness. You have felt the motion of the cosmos, the slow turning of the galactic disk, the great currents of gravity that carry everything forward. You have stood at the edge of a supermassive black hole and felt no fear, understanding that even in the dark there is balance and order. You have imagined distant worlds hidden in the dark, orbiting alien suns, perhaps harboring life, perhaps empty, but all of them part of the vast richness of the galaxy. You have remembered that you are made of stardust, that your atoms were born in the hearts of ancient stars, that you are not separate from the cosmos, but part of it, woven into its very fabric. And you have looked forward to a time when the galaxy will merge with another, transforming into something new, continuing the endless cycle of change and renewal that characterizes the universe. These are not just facts. They are reminders. Reminders that you are part of something vast and timeless, that you are connected to everything, to the stars above and the atoms within, that you are held by the cosmos, carried along on a journey that began long before you were born and will continue long after you are gone. You don't have to do anything with this knowledge. You don't have to remember it all or understand it all, or even think about it after tonight. It's enough just to let it wash over you, like waves on a shore, leaving behind a faint trace, a quiet sense of wonder. The Milky Way will still be there tomorrow night. The stars will still be shining. The galaxy will still be turning, patient and steady, indifferent to our worries and our fears. It has been here for billions of years, and it will be here for billions more. It does not ask anything of us. It does not demand that we understand it, or appreciate it, or do anything at all. It simply is, and we are part of it. And you are here now. You are part of this moment, this particular configuration of atoms and energy and consciousness, experiencing the universe from this unique perspective. You are rare, you are brief, you are beautiful. You are a pattern that will never be repeated, a unique arrangement of matter that has never existed before and will never exist again. You are enough. You are exactly enough. You do not need to be more than you are. You do not need to achieve great things or leave a lasting legacy or be remembered by future generations. It's okay to be small. It's okay to be brief. It's okay to be forgotten. What matters is that you are here, now, experiencing this moment, this breath, this heartbeat, this quiet connection to the cosmos. So, rest now. Let go of the thoughts that trouble you. Let go of the plans and the worries and the endless mental chatter. You have traveled far tonight, through space and time and wonder. You have seen the galaxy from the outside and felt it from the inside. You have touched the infinite and returned safely home. Close your eyes if they are not already closed. Feel the weight of your body, the softness of whatever you are resting on, the gentle pull of gravity holding you to the earth. Feel your breath, slow and steady, in and out, like the gentle rhythm of waves on a shore. You are safe. You are held. You are exactly where you need to be. The Milky Way is still turning. Right now, as you rest, the galaxy is making its slow rotation, carrying you along, holding you in its arms. The sun is orbiting the galactic center, and you are orbiting with it, traveling through space at hundreds of kilometers per second, and yet feeling perfectly still, perfectly at peace. The stars are still shining, billions of them, scattered across the galaxy, each one a sun, each one burning with nuclear fire, each one sending light out into the darkness. Some of that light is reaching Earth right now, photons that have been traveling for years or centuries, finally arriving at this planet, this moment, carrying with them the story of distant suns. The universe is still unfolding, slowly, patiently, without hurry or worry. New stars are being born in the dark nebulae. Old stars are dying, scattering their contents across space. Planets are forming around young suns. Somewhere, perhaps, life is beginning, taking its first tentative steps, starting the long journey from simple chemistry to complex biology to consciousness. Or perhaps not. Perhaps life is rare and we are alone. Either way, the universe continues, indifferent but not hostile, vast but not empty, ancient but still young in cosmic terms. And you are part of it all. You are part of this great cosmic story, this unfolding of matter and energy through time and space. You are a character in the narrative of the universe, brief but meaningful, small but significant, temporary but precious. Sleep well, traveler. Dream of spiral arms and distant suns. Dream of black holes and stardust. Dream of the vast, quiet beauty of the cosmos. Dream of worlds you will never see and stars you will never touch, but which are nonetheless part of your story, part of your heritage, part of what you are made of. And as you drift into sleep, let these final thoughts accompany you. The galaxy does not need you to understand it. It does not need you to save it or change it or do anything at all. It simply invites you to exist within it, to be part of its story, to add your own small light to the river of stars. And you have done that, just by being here, just by existing. You have fulfilled your role. You are enough. You are exactly enough. The Milky Way is still turning. Can you feel it? Not with your body, but with your mind, with your imagination. Can you sense the slow, majestic rotation, the patient wheeling of the stars around the galactic center? You are part of that motion. You are carried by it, held by it, swept along in the great cosmic dance. The stars are still shining. Can you see them behind your closed eyes? Not the individual points of light, but the soft glow, the gentle luminescence of billions of suns. That light is real. It is reaching Earth right now, photons streaming through space, some of them entering the atmosphere, some of them reaching the ground, some of them perhaps touching your skin even through the walls and roof of wherever you are. And you are part of it. You are stardust, briefly gathered into the form of a human being, experiencing the universe, aware of it, connected to it. You are the cosmos looking at itself, and that is a miracle. That is one of the most extraordinary things that has ever happened in the history of the universe. Matter becoming aware, energy organizing itself into consciousness, the universe waking up and seeing itself. Rest now. Let the cosmos hold you. Let the darkness cradle you. Let the light of distant stars be your lullaby. You are safe. You are home. You are part of something vast and ancient and beautiful, something that began long before you and will continue long after, something that holds you gently and asks nothing in return. The Milky Way is still turning. The stars are still shining. The universe is still unfolding. And you are part of it all. Sleep well, traveler. The journey continues even as you rest. The galaxy turns, the stars shine, the cosmos flows onward, and you are carried with it, safe in its embrace, held by forces you cannot see, but which are nonetheless real and constant and eternal. Rest, dream, drift, let go. You are home. You have always been home. And the Milky Way, your cosmic home, will be here when you wake, still turning, still shining, still holding you in its arms. And as you drift away into the soft darkness of sleep, remember this final truth. The universe is still unfolding. The Milky Way is still turning. The stars are still shining. And you, brief and beautiful, temporary and precious, you are part of it all. You are stardust, briefly aware, briefly conscious, briefly able to appreciate the beauty of existence. And when you sleep, you return to the cosmic flow, resting in the arms of the universe that made you, that holds you, that will always be there, turning slowly, patiently, eternally. Good night, traveler. Sleep well. The cosmos is with you, always has been, always will be. You are stardust drifting home. Rest now, rest. The galaxy turns. You are safe, you are held, you are home. You are loved by the universe in its own indifferent but constant way, held in the gentle embrace of gravity and light and time. Sleep, let go, drift. You are part of everything, and everything is part of you. The boundary between self and cosmos dissolves, and you become one with the turning galaxy, one with the shining stars, one with the vast, patient universe that has been here forever and will be here always. Sleep well. Dream of light. Dream of stars. Dream of the endless, beautiful dance of the cosmos. And know that you are home. You have always been home. And the Milky Way will hold you, gently, softly, forever. Sleep now. Sleep. The stars are shining. The galaxy is turning. And you are part of it all. Good night.